Okay, so we have a continuous beam, 3-span continuous beam. So first we have to find the static indeterminacy. So we have done already 5 minus 3 is equal to 2. So indeterminacy is 2. Then next we have to find the number of possible plastic hinges. The number of possible plastic hinges. So for that we have to see the moment diagram. So your bending moment diagram will be like this. So we have this is simply support A, B, C, D. So at the simply support the moment is 0. So it will be like this. At P we have some moment. Then we have C and then we have D. So this is the fixed end moment. Then the moment due to this the sagging moment. So that will be a triangular moment. So it will be something like this. So this will be your moment diagram. So from here we can see that this is the bending moment diagram. So here we have a peak moment, the hogging moment. So another peak moment will be here, and then we can have a peak moment in the span AB, and then one peak moment will be there in the mid span of BC, and another peak moment may be in this span here. Okay. So we have 5 locations. Number of possible plastic hinges will be 5. So one hinge can be here, and one hinge will be here. 2, 3, 4, and 5. Okay. So these are the 5 possible plastic hinges. So now we can find the number of independent mechanisms. The number of independent mechanisms. So which is same as the previous problem. Okay. The number of independent mechanism will be the number of possible plastic hinges. So maybe I will call it as n. So n minus r, 5 minus 2, 3. So again here also we will be having three beam mechanism we have to consider. Okay, 3 beam mechanism we have to consider. So that means the first mechanism will be like this. Mechanism 1. So first mechanism is there the beam AB is fail. So there is a failure of beam AB. So we have the beam ABCD. Okay, and span AB it can fail. So this span AB again we can take like you can consider like a probe cantilever beam. So we need only 2 plastic hinges. So one will be at this load point and the one will be at the support. So this is already a physical hinge. Okay, there is no need of plastic hinge here. So this failure will be or mechanism will be like this. So one plastic hinge will be here and one plastic hinge will be here, and this is my collapse load PC, and the remaining span there is no change A, B. So BC and CD there is no failure, and only plastic mechanism has formed in the span AB. So in this ABCDB, your AB span is going to fail. So that is what the mechanism wants. So for this mechanism, again we can easily solve it, like we can use the upper bound theorem. So this angle will be theta. So I can directly take the result, and otherwise we can solve also. So this angle also will be theta, because this plastic hinge will be forming at the, I think it will be forming at the midspan. It will be at the midspan because below the concentrated load we will have a plastic hinge. Okay, below the concentrated load we will have a plastic hinge. So there will have the peak moment. So this will be the mechanism. So I can use the external work done is equal to internal work done. That is your equation equation. So external work done, that is PC into delta, and the delta is the displacement at this point. So external work done, that is PC, collapse load, into delta, which is equal to your internal work done. So at this section we have MB. So when we come to this section, this plastic hinge, so here we have MB and here it is 0.8 MB. So this at this point we have to take your plastic moment value, we have to take the least value. So we have to take the least value, so 0.8 times MB. That is a crucial point. That is a probable mistake usually we will make. So with the internal work done, that is equal to MB into theta plus MB into theta. Okay, so MB theta plus MB theta plus, and here we have 0.8 into MB, 0.8 MB into theta. Okay, so that is 0.8 MB theta. So finally this will come 2.8, 2 plus 0.8, so 2 MB theta, and where theta will be equal to 2 times delta by L. Okay, theta is equal to delta by L, so we can write 2.8 MB into theta equal to 2 delta by L. Okay, so delta will be getting cancelled, so finally you will get your collapse load is equal to 2.8 into 2, 5.6 MB by L, 5.6 MB divided by L. So this is my collapse load in the mechanism 1. Okay, so that means what is the meaning is, so this is the load required 5.6 MB by L. This is the maximum load this span AB can carry. At this load value, this span A, there will be a failure of span AB. Okay, so that is the first mechanism. Similarly, we have to take another two mechanism. Mechanism 2, that is your span DC, and mechanism 3 also. So mechanism 2, so there is a failure. Okay, so the span BC is going to fail. So in the span BC, we'll be having 3 hinge. So you can take it. You can take like a, you can take it like a fixed beam only. So you will get the same result. So one hinge will be here, one hinge will be here, and the third next hinge will be here. So again, if we have a fixed beam with a point load at the center, okay, so I think we'll be having the your collapse load is something, you have some equation 8 MB by L, 16 MB by, something like that. We have some equation. That equation maybe you cannot use it directly. Yes, we can use that. Only thing is you have to replace the MB with 0.8 MB. Okay. So anyway, we will not use the equation. We will just derive it. So these are the 3 plastic hinge. So this is your theta. This is my this angle theta. All these angles are same, equal, theta. Okay. And here we have the collapse load. Here we have the load PC. So other span, there is no mechanism. There is no failure. Okay. So that is why we are not taking the work done by the other forces. Here also we have some force. Okay, but there is no mechanism like this, so there is no displacement actually. Okay, so we are not taking that. So we are only considering the failure of the span BC. So again we will be using the same equation. The external work done equal to internal work done. So external will be equal to PC. So PC times this one delta. So PC times delta, and internal work done will be, so we have plastic hinge here. So this moment is 0.8 MB. Okay, and this is also 0.8 MB. So everywhere we have 0.8 times MB. So also 0.8 MB, and here also 0.8 times MB. So we can write. So here we have 0.8 MB into 2 theta. So here another one, here another. So finally 4 times 0.8 MB theta. So 4 times 0.8, that is 3.2 MB. Theta is equal to 2 times of delta by L. Okay. So this will be equal to, finally your delta will get cancelled. So PC equal to, you will get 6.4 MB by L. So this is your failure load for this span, second span BC. Okay. First span AB, we have 5.6 MB by L. Second span 6.4 MB by L. So in this question, all the load is acting at the center. Okay. All the load is actually at the center. So we have to write that also in the question. This is L by 2. This is L by 2. All are L by 2. It can be different also. So if it is different, there is no change. There is no difference. The same procedure. So accordingly, you will have theta 1 and theta 2. So you have to solve that. Like we have solved the fixed beam with eccentric loading. Same procedure you have to follow. Okay. So in this question, just for simplicity, everything is at the center. It can be at the different. This can be 3 by 4L. This can be L by 4. So then you have to follow this procedure, but this theta 1 and theta 2 will be different. It will not be equal. So accordingly, your PC value will be different, but same procedure. Okay. So that is your second mechanism. And mechanism number 3. The third mechanism will be similar to the first mechanism. Is it same? Yeah, it is going to same. Okay. Third mechanism can write same on your mechanism 1. Same as the mechanism 1. So you will get the collapse load, which will be, you will be getting 5.6 only. 5.6 MB by L. Third mechanism and first one will be same. So you will get the collapse load is equal to 5.6 MB by L. Okay. So now you can answer your question. What is the collapse load for the given beam? What is the collapse load? So that means this much load is required. So this span will fail. If you have this much load applied, then this span will have failure. So the least value you have to choose, because at a load of the least value means this failure will happen first. So first this mechanism will be happening in the beam. So in this beam, if you keep on increase all these loads, so here in the span AB and CD, you will have mechanism will be forming simultaneously. So that will lead to the failure of your continuous beam. Okay. So finally, your answer for this the question will be the collapse load, which is equal to 5.6 MB by L. Okay. The least value, the least 1, 2 and 3. Okay. The least value you have to take it as the collapse load. So this will be the answer. The least value of 1, 2 and 3. So this is for 3 and it is for 2 and this one will be the first. So that is the procedure you have to do. Okay, you have to do like this. So I think we have done 2 questions. Maybe this is a beam with UDL and this is the beam with point load. So whatever is the loading, this is the procedure you have to follow. Okay. So the third mechanism I did not draw. It is same. Okay, same as the first one. It is like this. So first span, second span, third span. So we'll have hinge here and here. So this is my collapse load. Okay. So here you have to take MB. Here we have to take 0.8 MB. That is same as the first one. 0.8 MB MB. Okay. So that is the question number 12. Okay. So if you have any doubt, you can ask.
Sir, if instead of 0.8 MB we have MP, then can you use the equation MP whole into L plus B divided by AP in mechanism 1? Or we have to derive like the way you derived only?
No, if it is everything is uniform, this then you can directly use the equation for a propped cantilever beam with this case.
Hmm.
You can directly use that. So even in second span you can use the direct formula. So I don't think you will get a different answer. In the second span everything is uniform, 0.8 MB only. So fixed beam with point load, I think we have the equation, direct equation. We can use that.
Yes, sir. And 6.4.
Yeah. So we can use that. So okay, and we'll go to the next question. So question number 13, you can directly solve it. This question we have not done. We have to, till now we have solved what? We have solved how to find out the collapse load. So question can be also asked like you have to find the required plastic moment of resistance, MB. Okay. So but we can do this because we will be solving one question is there for the frame. Okay. There's a question for the frame. So we have to find the plastic moment of resistance. So this one we will solve in the class anyway. So after that you can easily solve this beam problem. So this concept will be explained there. Okay. So I am skipping this question. If you have time, we'll come back. Here also you can directly use this. The only thing is that the ultimate load is given. Load is given, so we have to find the MB value. Okay. So like we can use the fixed beam with the UDL second span. We have some equation. Okay, we have some equation like 16 MB by L, something like that. So from that collapse load equal to 16 MB by L. Let us say that is the equation. Then the load is given and MB value you have to find. That is a reverse process. That is I can do that. So 13, question number 13, I'm skipping, and we will go to question number 14. So again the question for finding out the collapse load. So this is also a typical question for like for the gate examination. You can see this type of question used to ask. So here we have it is a fixed beam. So static indeterminacy R is equal to 4 minus 2. It is equal to 2. So what is the number of possible plastic hinges? So how many hinges we have, or we can have the number of possible plastic hinges. So how many hinges are possible in this case? So we can have one hinge at the fixed support, one hinge we can have here, and if you draw the moment diagram, it may be something. Maybe it will be something like this. So we can have a peak moment below the point load. So one hinge may be possible here, and here the cross section is different. So this is MB, and it is 2 times MB. So these are the possible locations. So we can have 4 hinges. Four hinges are possible. 4 locations hinge may develop. Okay. So the number of possible plastic hinges are 4. So then I can find the number of mechanisms. The number of mechanisms, that is 4 minus 2. Number of possible plastic hinges minus static indeterminacy. So the number of mechanisms, that is equal to 2. So 2 mechanisms are possible. Okay, 2 mechanisms are possible. So what are those mechanisms? The first one is, so in this case, to form a mechanism we need 3 plastic hinges. Okay, so to form a mechanism we need R plus 1 plastic hinges. So indeterminacy 2, for to form a mechanism, to form a failure mechanism, so there should be 3 plastic hinges. Okay, so we will take 2 cases. The first case is these 2 hinges are forming at the fixed support. Okay, because the fixed support and the peak moment, maximum moment will be at the 2 support. So the first 2 hinges will be forming at the support, and third hinge we will take it at the point of application of the load at this point. So your load is acting at the midspan L by 2. This is L by 2. So that is the first possible plastic hinge. So we can have two hinges. First two hinge will be forming at the support, and you increase the loading. Further you apply the load, then the third hinge may form at the midspan, wherever your point of action of the load at that section you have a peak moment. So that section may reach your plastic moment. This is the first possibility. So we have four hinges. So what is the value of MB at this support? Here we have MB, and at this section, what is the value of plastic moment capacity? That is also MB. This is also MB. But at this section we have 2 MB. Okay, and this angle will be theta. So this is at the midspan. So all these angles will be theta only. Okay, so these angles are theta. So this is the first mechanism, and you can solve that. And second mechanism will be the first two hinges are forming at the support. First two hinges are forming at the support, and the third hinge will be at this section L by 2 at a distance of L by 4 from the support B. Okay, at this point your plastic hinge may form. So that is the second possible mechanism. So okay, so we take here, this is the third hinge, first hinge and second and third. Okay, and in this case here we have MB, and here we have 2 MB, and this angle will be maybe theta 1. This angle will not be equal, this will be theta 2. Okay, this is mechanism 2. Okay, mechanism 2 I am drawing. So what is the value of MB at this point? What is the value of plastic moment at this point, at this junction? You have to take the least value. So we have to take the least value of MB and 2 MB. The least is MB, so this is MB. Okay, so now we can solve these two mechanisms. If you take the first one, where we have the load at this point at the bedspan. Okay, so here let me write. So this is L by 2. Okay, the plastic hinge is forming below the point of action of your load. Load is acting L by 2, and here my load is acting here only. Okay, so here this is the plastic hinge location, but load is here. Load is here. Okay, so let us try to solve that. This is simple. We can solve it. So like external work done, that is your WC into delta, and this is my displacement delta, that is external work done, WC into delta. It is equal to MB into theta plus, when you come to here, MB into 2 theta, so 2 MB theta, and here 2 MB into theta. Okay, 2 MB into theta. Here 2 MB is the moment capacity in times theta. So total we have 2 plus 2, 4, 5 MB theta. So theta is equal to 2 times delta by L. Okay, 2 times delta by L. So that is 2 delta by L. So maybe you can write WC, the collapse load WC, that is equal to 5 into 2, 10, 10 times MB by L. This is the collapse load corresponding to this mechanism number 1, mechanism 1. So we have to check how many mechanisms? We have to check 2 mechanisms. Okay, for the first mechanism, to have the failure or to form this mechanism, we need, this is the collapse load. 10 times MP by L you have to, that is the collapse load value. So in the second case, we have to do the same thing. So what is the internal work done here in the second case? Okay, I think we will do this in the next page. So this question is simple, but so we may make mistakes sometimes. Okay, so we'll do that in second mechanism. First mechanism, I think it is clear. So a collapse load is 10 times mp by L. And second one, so what is your internal work done? Internal work done or strain energy, that is where. So here we have mp into theta 1, mp into theta 1 plus this will be theta 1, this will be theta 2. Okay, so mp theta 1 plus mp theta 2. Okay, plus 2 times mp, 2 mp theta 2. Okay, and let us take this is delta. So then your theta 1 is equal to delta divided by delta by 3L by 4. Okay, delta by 3L by 4. So this is equal to 4 delta by 3L. And theta 2, that is delta by L by 4. Okay, so that is 4 delta by L, because this distance is L by 4. Okay, because the plastic hinge is formed at this point, maybe A, B, C. Okay, this is where point C. Okay, and this point is D. In this case, our plastic hinge is formed at third hinge was at point D. Okay, so that is theta 1 and theta 2 I can write in terms of delta, and that is the internal work. That is what is the external work done. What is the external work done in this case? How will you find? W into we have to multiply with the corresponding displacement, not the delta. We have to multiply with this is where external work done will be the force multiply with the displacement at that point. So W into delta 1. This is delta, this is delta 1. So how will you find the delta 1 in terms of delta? We can use a similar triangle. So I can write delta, so divide by this is 3 by 4 L. Okay, delta by 3 by 4 L. So divided by, equal to delta 1. So what is this point? The point of action of the load is at the midpoint, right? This is point D. So this is L by 2. Okay, so this distance is nothing but L by 2. Okay, so delta 1 by L by 2. So from here you can write delta 1 is equal to, we can just simplify this for delta by 3 times L. Okay, 4 delta by 3L, 2 by L. I think I'm correct. So 4 delta by 3L, into L by 2. This is reverse. So L will get cancelled, 4 and so this will become 4 by 2. So 2 delta by 3. So delta 1 is equal to, we got delta 1 is equal to 2 delta by 3. Okay, so this is equal to W collapse load into 2 delta by 3. So now we can take this equation. So I can take this equation and we can substitute everything. So we have the collapse load WC into 2 delta by 3 is equal to mp theta 1. So 2 times 2 mp theta 1. So this 2 I can combine. So that is 2 mp into theta 1. Theta 1 is 4 delta by 3L. Okay, 4 delta by 3L plus this is 3 mb theta 2. So 3 times mb into theta 2 is 4 delta by L. So which is equal to, so 4 into 2 8 mb delta by 3 L. Okay, this is 3 into 4 12 mb delta by L. Okay, so we have to 3L. So 36 plus 8 44 44 MB delta by 3L. Okay, so that is, here we have WC 2 delta by 3. So all the delta will get cancelled. This delta and this delta I can cancel. So maybe this one also we can cancel. So here WC will be equal to 44 MB by 44 by 2, so 22. So 22 MB by L. So that is the collapse load. In the second mechanism, WC equal to collapse load is equal to 22 MB by L, and in first 10 MB by L. Okay, so finally the collapse load is, your answer will be the least value. Equal to the least of 1 and 2, which is equal to 10 times MB by L. Okay, 10 times MB by L. So this is how you have to solve it. Okay, the question looks it is simple and small question also, but this is the thing. So I think this part is simple. Mechanism 1 everybody will do. Okay, mechanism 2 sometimes we may miss. So we may not take this case sometimes. And sometimes we will take this one, but unknowingly we will make a mistake, W into delta. This delta will multiply. That is another probable mistake. So we have to multiply W in delta 1. Then you have to do this procedure. So this type of question is to come in GATE examination for 2 marks. Okay, so we have to do these two mechanisms, then you have to take the least value, and but every time there will be option will be there, both this will be there in the option. Okay, in the one option may be 10 MB by L, another option may be 22 MB by L. Okay, sometimes by chance somebody have done only the first mechanism, and they will mark this as answer, but they will also get the mark because second mechanism is giving the higher values. But always it will not be like that. That is your luck. Sometimes even though you have missed this mechanism, but still you will get the correct answer because the first mechanism is giving you the least value. But always that will not be the case. Okay, so to be in a safer side, we have to solve these two and then you have to get your answer.